area. I was in here.
Yeah, but we
Perfect.
also
Thank you.
only
Cool. Thank you
have
so
one.
much. Fabulous.
We also only have one.
And that may be okay.
Maybe they used our other one.
No, yeah, many ways to fail, right? What am I doing? Yeah.
So you're running the slides, right?
Sure. Yeah.
An hour from now.
Yeah, 1 hour.
Yeah. It'll seem like more. You laugh. Jesus. Okay.
Try, just try.
Here. Cool. And what do we got? So everybody's all uploaded and everything, right? That, okay. And show me meeting materials. Yay. Fabulous. Cool. Slides and okay. Fine. Sorry, I'm obviously incompetent.
Just for the recording.
What are you going to do? Recall me? That one. And this should be that. And then that should be that.
Take a walk, but
And what do I do? I remember this joke. Yeah. Anyway. How do you do this kind of thing? It doesn't matter. Cool. We can start. This is close enough. So if you're in TSV area, you're in the right place, and that means we're in the right place too. And if you're not in TSV area, you probably should be looking for where you are. We're getting a start just a couple minutes late, but that's not bad for a slow start.
Oh, we need a minute taker, do we? We need.
So we have the blue sheets coming around. And we have an area director doing a last minute grab of a scribe. This will take just a moment. While we're doing that, you can review the note well, which is much like what else you will see this week as the second slide in pretty much every presentation. So we are Monday afternoon, session 3 with this agenda. Is there anything that that anybody needs to do to the agenda that we need to bash it? Hearing no hearing no suggestions, we will blow forward. So anyway.
Yeah, I found a minute taker in the meantime, so thank you, Magnus.
Excellent. We always try to say thank you to the TSV area review team, and I want to do a special thanks this time to the people on the triage team, Wes, Magnus, and Martin. This is looking good now, and this is looking better. I think this is going to be looking better in the next IETF cycle. But we're way more hooked into the data tracker now than we have been in the request tools and stuff like that. So I want to thank the people whose names are in bold, who did reviews for us. And these reviews really help. I mean, both Mary and I have balloted fairly serious ballots, that started out with the transport area review team reviews. So thank you for that. Talk a little bit about the updates. I'm going to just blow through mine real fast. The delay tolerant networking, the BIS draft for the bundle protocol is past working group last call. The TCP convergence layers in working group last call, and BPSec is still in progress. IPPM, the fun thing I wanted to do for that was we are finally updating RFC 2330 for IPv6 because we hear that's going to catch on. That's in AD evaluation right now. And I wanted to also notice that there were 9 working group drafts that were revised for this IETF meeting. So pretty pumped about that. NFSv4 is not meeting at IETF 101 because they're at a hackathon. That is an excused absence. Quick continues to focus on the Quick core protocol specifications for Quick version 1 in November. TAPS, since the last IETF, rechartered to allow analysis of transport security protocols as well. Those were explicitly out of scope when we chartered TAPS. They are explicitly in scope now. And they're going to be spending some time on that, some agenda time on that this meeting, if I'm remembering correctly. TRAM is finishing up their final deliverables. StunBIS is on the next telechat, and TurnBIS is in working group last call. And TSVWG is indescribable because they have 11 working group drafts that were updated for this IETF meeting. Miria, would you like to share your thoughts?
So I just want to highlight those groups that are trying to wrap up some of the work. So Alto is really trying to finish their current milestones, and TCP Inc. is basically mostly done. One of the documents is already approved. The other one is in IESG evaluation, and the third one we will process hopefully quickly. So I hope I can press some close working group buttons soon.
Excellent. Especially when the documents are not. No, I'm sorry. Did I say that out loud? We should have introduced ourselves. You are.
Mia Kühlemann.
I am Spencer Dawkins. I am the outgoing area transport area director, and that's next March. But I want to get used to you guys hearing it, so I want to get used to saying it. We got lots of stuff done, and the thing I want to call especially attention to this time is the number of things that slid all the way through to being published RFCs. I'm getting really impressed at the stuff that is coming out of the working groups on my side of transport. I hope you're having the same experience.
Yes.
But I mean, like, we haven't had one that was mostly RFCs published since I joined the ISG. So, like I say, thank you for continuing to do a lot of work and continuing to do work that is easier to get through the publication process and into a form that more people will see it and more people will use it. Anything on that one?
No, thank you.
Cool. We are doing a short advertisement for this draft from Fernando, and this is about IPv6 address usage recommendations. It's being chatted about in TAPS. TAPS is actually working on things like connection racing. They've been thinking about things like choosing between paths and choosing between transport protocols. But there's also a choosing between IP address families topic that's relevant. And the answer you get is probably going to depend on how you do the racing. We're not going to talk about that in here. Please keep an eye on it if you're interested, because the impact is way wider than TAPS. Thanks. We would like to call Tommy Pauly to the stand to talk about experience with TCP encapsulation for IKE.
Yeah, and after the presentation, we will have a little bit room for open discussions because we see more and more protocols that request TCP encapsulation, and we would like to get some community feedback on those approaches.
All right, hello everyone. I'm Tommy Pauly from Apple, and the area directors asked me to just talk about some TCP encapsulation experience that we've had. This is mainly just one use case that we've had for using TCP as a encapsulation tunneling strategy that we have done in the IETF. I mean, we've also done measurements around. There are definitely others, but hopefully this can give a starting to the conversation and some light into that. All right, so next slide, please.
Cool, thank you.
All right, so why were we looking at TCP encapsulation at all? So we were looking at this for IKE and IPsec over UDP traffic, particularly in the cases in which NATs and firewalls are badly treating our UDP traffic. This is not everywhere, but when it happens, it's pretty bad. So even in the good cases in which UDP can get through the networks, ESP traditionally, when it's going over a NAT, recommends having a 20-second keep alive timeout, so that you send if there's no other traffic, you send a UDP packet every 20 seconds just to keep the NAT happy. That's pretty terrible for radios and power. But then beyond that, as of when we started this work back in 2015, we were seeing somewhere between 3 and 8% just total failures for getting any responses over UDP. This is generally UDP port 500 and 4500, and that generally is not too terrible of an issue. Traditionally, we think of IKE and IPsec being used for VPN access, so sometimes that just doesn't work when you're at your hotel. It sucks. Other strategies include a lot of proprietary TCP or TLS based VPN solutions, which are presumably doing something like TCP encapsulation, but they're not quite public about how it's being done. But this became more of a problem because we were using IKE for doing things like Wi-Fi calling. So this is telling back to your carrier. And so if you're roaming internationally and you're at your hotel and you want to make a phone call, and that just would fail all the time because of YouTube being blocked, that was a more critical problem than just the enterprise use case. So it had more visibility for us. And so this is mainly being blocked on captive networks, hotel networks, cafe networks, enterprise networks. I think we saw higher failure rates in like Asia, it was less of a problem in some of the US markets and more of a problem internationally. And of course, TCP gets through the networks with a much higher success rate. And to some degree, it's even better when you just look like HTTPS traffic. So next slide.
We're there.
All right, perfect. So what this turned into as work was something that has been published in RFC. This is RFC 8229, which is TCP encapsulation for IKE and IPsec. So what it defines is how to take a series of traditionally UDP IKE v2 packets and traditionally UDP encapsulated ESP packets that normally go over port 4500 and stick them over some stream. So the RFC defines sending those messages over port 4500 for TCP. You can configure other ports if you need to get through evil middle boxes, but as IETF, we don't like sanctioning that usage. We decided to begin the stream with a stream prefix such that whoever opens the connection sends essentially a little bit of magic bytes saying that I'm doing this TCP encapsulation thing. The main point there was that we are concerned that there are existing deployments of proprietary non-standard IKE v2 over TCP implementations that have been run by other companies, and we wanted to really differentiate this standards-based version from those. The actual strategy of encapsulation is very, very simple. You just have a 16-bit length field at the beginning of every otherwise datagram, and you send that, and then you send what you would send as your datagram, and then you send another length field, et cetera, et cetera. So it's really, really minimal. It essentially just takes your traditional IP packets and put UDP packets and sends them over the TCP stream instead. This is kind of multiplexing multiple protocols here because we are running both IKE and ESP. But luckily, this particular issue was already taken care of by UDP encapsulation for ESP. So that strategy is putting, if the first 4 bytes of the message are all 0, then it's IKE. Otherwise, it's going to be ESP packet. So it's a multiplexing basic TCP encapsulation stream. So it works. That's how it functions. But then how does it actually perform, and when do we want to do this or not? Next slide. So there definitely are concerns with this approach. We recommend quite strongly in the document that it is only something that you should be using as like a fallback when you don't have access to the network over UDP, or there are particular problems with that. So there are a number of issues that we were concerned about and we tried to measure and look into. So the first is around what happens when you have TCP within TCP and when you're dealing with packet loss. Generally, what happens here is a loss on the outer TCP connection turns into what just looks like a delay to the interior TCP connections, because it's going to be a reliable stream on the outside and will eventually deliver the lost packet from the perspective of the inner connections. So this can induce a fair amount of burstiness so that you won't see a lot of loss, but you'll see a whole bunch of retransmits or other things on the interior connection coming at once. We also ran into concerns with window size issues, because if you have inner connections and outer connections, especially when you're running ESP within this, and so you're running 2 levels of TCP, they'll both have to do a slow start, and if there are problems that occur on the connection, it's much more likely that the interior connection will kind of fall back into a slow start and overreact when there are any issues on the connection. And of course, whenever you're running something over TCP that's not traditionally over TCP, you're adding a lot of head-of-line blocking and reordering that you wouldn't have over UDP. So if you are doing multiple streams here, that does cause issues. And later on, Stuart, if you would like to comment on anything, Stuart was also involved in a lot of the measurements and discussions around this when we were first looking at it. All right, next slide. So when we were first doing this, we did run a number of performance tests to try to understand how is this TCP encapsulation thing going to affect our traffic. So the setup was that we had essentially just a standard vanilla IETF2 VPN server. And in front of it was put the relay box that would do the translation from the TCP encapsulation into the standard UDP packets that were going to be expected by that VPN server. The client side was modified to take the packets that it was already going to send for IETF2 and ESP and just encapsulate them, like we mentioned before, into that TCP stream. And then for the actual performance tests, we ran multiple instances of iPerf doing TCP through that tunnel to see how it would be affected by various changes. And so when we're doing those tests, we had several variables that we were looking at. First, what is the strategy for encapsulation? So we ran, as a control, just iPerf without any tunneling at all. We ran it with just ESP directly over IP, so a completely unencapsulated version of that, but still using encryption on a tunnel. We ran that with ESP over UDP, so the standard encapsulation, and then also ESP over TCP, so using TCP encapsulation. And then the 2 ways that we tried to impair the link were to induce a fixed random loss between 0 and 3% using a Sarah router. This is fixed and random, so it's not necessarily truly realistic, but it's a number and a value that we can look at to get a good picture of what are the basic reactions of a TCP encapsulated connection here. And then also we modified the delay anywhere between 0 and 500 milliseconds added in the Sarah router. All right, so next slide. So here's the basic results that we saw when we were playing with loss. So the top blue line that looks pretty good is just the iPerf over just a direct connection, no ESP going on at all. So we see here that we're on around 100 megabit link. And then as we increase loss up to 3%, that does degrade fairly strongly. The green and yellow lines, which are the ESP directly and ESP over UDP, track pretty closely to each other. They do degrade pretty quickly when you have loss, and this is just having the normal encrypted non-TCP encapsulated link get impaired by loss. It was interesting what we saw when we did run it over TCP. Actually, at the lower levels of loss, we saw better performance overall for the throughput, and we believe that's mainly because the loss was being hidden and turned into a somewhat minor delay. And so the interior connections wouldn't actually see the same negative effects until it got much worse. But once we reach around 3%, then the throughput for that TCP encapsulated link does tank and become quite bad. So while it's good, it's pretty good. And when it's bad, it's quite bad. But when your alternative is essentially no connectivity whatsoever, and you also take into account that even the unencapsulated versions at 3% loss are relatively poor compared to the normal case, we believe this was a reasonable trade-off to take. Next slide. And then on the delay side, we saw slightly less impact. Again, the unencapsulated, unencrypted version does quite well. And then the TCP encapsulated version tracks pretty closely with what we see for the UDP and IP encapsulated versions of the same test. So on that end, it was relatively performant.
Next slide.
Next slide. I think there's, yeah, last one. So the conclusions we drew from this were that the TCP encapsulation does work, and is certainly preferable to no connectivity at all when we have UDP-based protocols. We did make sure to do this in IETF because we wanted to have an actual standard solution for doing a TCP or TLS-based VPN, which was not possible before. The performance is tolerable. It degrades roughly at the same points as the other approaches, but it does have some pathological cases. And I'm sure that if you did a more thorough investigation of this, there would definitely be certain scenarios that behave quite badly with TCP within TCP. Some of the areas that we think could be very interesting to look at if we do see this become more common, that we have TCP encapsulation as a strategy, is tuning that outer TCP connection, maybe make it a little bit more intelligent about what traffic is going through it, especially when we have multiple TCPs within each other. It'd be interesting to see what are the right ways to pass ECN markings through. Should you even create your own ECN markings when you know you're experiencing loss on the outside? Should there be any coordination of the window sizes of the various connections with each other? Some of those approaches we believe could mitigate some of the pathological cases, but we haven't fully explored those. So that's it.
Any questions, please come to the mic. Please remember to state your name as you're talking for the scribes. Thank you.
Hi, Vladimir Oltanu, UPV. So I've had a bit of success running TCP inside of TCP. If I marked the inner TCP packets with congestion experienced whenever the outer connection experienced losses. So,
okay, yes, that was one of the approaches we were thinking of. So if that works, great.
I mean, it doesn't work perfectly, but
Sure.
It's better than nothing.
Okay.
Tom Herbert. So when I first saw this presentation, I was slightly alarmed because I thought this was going to be STT. Are you familiar with that?
No.
So STT, the idea was to use TCP as a header format, but not, they were encapsulating with that.
No.
So might be nice on slide one just to make sure this is encapsulation within an actual TCP
Within a
stream,
true
not just
TCP stream.
using
Yes.
TCP header format. But I
Yes.
did have a question on the performance. Can you consider in the UDP case, if packets are out of order, you can actually deliver out of order packets, whereas in TCP you have to wait for
Yes.
all of that. Did that have an impact on performance?
So in these particular tests, not so much because they weren't really targeting that. I think you definitely would see that, especially if you had more connections running in parallel when we're running iPerf here, they already required a fair amount of in-orderness between them because there was a lot of packets there. But if you have a lot of bursty small connections that really have no relationship to each other, then I imagine it would be a lot worse whenever there was a loss or delay on that
Or
connection.
just use multipath TCP maybe.
My name's Stuart Cheshire from Apple, and I think the thing that Tommy was hinting at earlier relates to this. A couple of years ago, we did some work with John Iyengar recently at Google, and he had, when he was a research professor, had a protocol called Minion that was an extension to TCP that allowed delivery out of order, and we were very excited that this would give big benefits. And it didn't, and it was kind of a surprise. And it turned out that TCP's in-order delivery model is actually not bad, because most applications need data in order. An HTML page or a style sheet or a video stream doesn't work. If you're missing the iframe, then all the P frames and B frames that depend on it can't be decoded. And when the packet loss rate is only 1 or 2%, most of the data is in order. So the number of opportunities you have to deliver data out of order is small, and the number of situations where that's helpful is even smaller. So that was educational, because we'd gone into this confident that Minion would show these huge benefits, and we were kind of surprised that not as much.
Right, that makes me think, like, if we had some use case, not like the current use cases that you mentioned, that was naturally much more loss tolerant, that expected, like, as we see, these particular loads we were putting over here already degraded heavily whenever you hit 3% loss. If you had another type of load which was perfectly happy to receive a bunch of loss on a UDP connection, then it would see a much worse degradation by adding it.
Yeah, I think a lot of the thinking in this space goes back a long way. Before TCP had fast retransmit, and if you lost a packet, you're waiting for a timeout, that was a huge performance penalty. With fast retransmit, it's one round trip later, the missing data is filled in. So you're left with the sweet spot for this out of order delivery is stuff where one round trip is too long to wait. And that applies for video conferencing person to person. It doesn't even really apply for YouTube or Netflix video streaming, because a half-second playback buffer is ample to cover one round trip.
Right. And the fast retransmit here is critical to making this work well.
Lars Eggert, so I wonder, the stats you showed in the beginning about UDP not working over a bunch of paths, have you seen any change in the last 2 years? Has it gotten better?
I don't have the updated numbers on that. I was looking for that as I was putting these slides together. No, I mean, it seems to be relatively similar to what I've seen for the quick UDP intolerance numbers that were given initially.
So I'm asking because sort of 2 years is basically the time Quick has been around. And so one prediction could be that if Quick gets deployed more, it's going to push UDP into networks where it currently doesn't work well, simply because people will want to fix that, right? So there's one potential future where the need for this kind of encapsulation might go away because UDP is going to work better. However, we don't know.
Right. And it's still a concern that even if UDP packets do make it through, and maybe only certain ports for Quick would make it through, that the NAT timeouts for UDP ports that are not well recognized are not going to be treated well in lieu of some other connection type header. So the cases in which I need to be able to receive a phone call and I'm just essentially camping on a NAT for a really, really long time, sometimes does work better when we have a TCP connection to leave that NAT mapping open.
Right. So it doesn't do anything for NATs. Right.
Hi, Luigi from Telecom Paritech. I was looking at the first bullet here, and I'm thinking, if a protocol is being designed to use UDP, there is a reason. So maybe it doesn't want all the heavy machinery that comes with TCP. Now you put that protocol on TCP. Is there any negative impact on from the TCP machinery on the protocol? Have you thought about that?
Yes, I mean, I think all of the things that we're looking at here are the negative side effects that we're having from using TCP instead of UDP. This particular case, I imagine, is one of the worst because the previous use of UDP was to tunnel many, many, many TCP connections in all of their IP packets, a case in which you really don't want any relationship between the delivery of those packets. And so I imagine other direct UDP applications that aren't necessarily about tunneling would experience similar effects, but hopefully less than this.
Let me be outrageous.
Okay.
What if there is a way to turn off the congestion control or some part of the machinery of TCP when the purpose is just to go through middle boxes?
Right, and that starts to get into some of these other approaches of, oh, just use TCP as the header to get through, and that gets into a pretty messy space, I think. Yeah. Open discussion.
Yeah.
Do you want to stay here? It doesn't matter. So thank you very much. I think,
Thank you very much. Definitely.
yeah, I think this was really good to understand the main use case we see and some of the problems. So we would like to actually get some feedback from the community. Can you go on the next slide? There should be another one. One more actually.
Okay.
So this was just a few. Oh, this is not really how it's supposed to be. Wait. So just out of my head, I put up some few RFCs that were recently published and drafts that are kind of under submission or really work in progress, early work in progress, that kind of cope with the same use case and the same problems. So we see this more and more often. It's not like one use case where we see mailbox problems and where people think that TCP encapsulation might be the solution to their problem. And therefore, basically, what we would like to ask the community is two questions. First of all, what do we think about this? Is this an acceptable approach? Do we know any better? And no matter what we think about it, do we have to provide more guidance to the rest of the community outside of the transport area how to do TCP encapsulation correctly? Any thoughts?
Hi, Tommy. So just one thought based on that. The RFC that we did for Ike was in the security area, so it's not a group of people who are used to transport necessarily. It was very useful to get the transport area's review on it, but when we were doing it, it would have been really useful if we had a document to refer to that essentially gave, here are the guidelines on how to do this and when it's a good idea to do it or not, and the pitfalls that you'll hit. And we essentially wrote up a large, performance consideration section in there. And it would have been great to have just another RFC to point to, like, look at this. This explains all the problems.
I mean, to other areas, it's also not clear that, TCP is a streaming protocol and UDP is a data protocol. And if you put data on a streaming protocol, then you probably need to figure out where your message starts and ends. So these are, very general stuff. We think they are not very complicated, but writing them down as a reference might make sense.
Hi, Brian Dremel. I got up because nobody was getting up. No and yes. So 1, no. 2, yes. Question for Tommy. You've done a lot of the work in order to make this document make sense. You already did a lot of the work for writing the guidelines document. Can we use that text as a starting place?
Yes.
I think we should do that. And I think it should be, it should probably capture the no answer in one, but it's don't do this, but we know you're going to do it anyway. So here's how not to blow your feet off. Right.
So if people have this problem and the answer is don't use TCP encapsulation, what's the alternative?
Right. They're going to do something even worse. Right.
I don't know. I don't even know
for example, we just heard you can put TCP headers on things that aren't TCP. So that would be another way to do it.
Yes.
So, we're here. So, and actually this was a Petrakucha slide of mine, right? What happens when you run TCP and TCP? And that was, I realized when you were giving this talk, that was in the pre-fast recovery era, right? That was in the 90s when everything would RTO. If you look at it funny, it'll RTO. And that's gone away now. And okay, so which means if it works, if these sort of approaches work as well as they do up to 3% loss, then how many VPNs are running over PPP over SSH now? Probably a lot. I think that a guidelines document here would be useful. And I think you should author it because you already wrote half the text. So cool, thanks.
Kyle Rose. So I was just thinking about the question that was asked earlier about what if the title protocol doesn't like what TCP is doing somehow. And it got me thinking about what could be one application of that. And maybe the protocol running over UDP actually cares about packet loss. That tells it something about the network, or maybe it's trying to figure out information about the network to maybe fall back on something else if there is packet loss. Would it be possible to give access to that information, those metrics from the TCP layer up to the upper layer protocol?
So this kind of reminds me of the guidelines for ECN in tunneling protocols. I think you can find a lot of synergy there. So if I'm running something that is expecting, like as an application, I'm expecting UDP, but I happen to be tunneled over TCP, I could either see the idea of, TCP gets a loss, it actually fixes it, but then it tells the application, you lost the packet, or it just never delivers it. So you could do that, or you could deliver the UDP datagram, but make sure that the UDP API gives sufficient signaling of ECN bits, and essentially you add on an explicit congestion experience bit onto there to make it look like, hey, it's as if a router saw a loss, so you should react as if there is that. So that's a good reason to have ECN APIs for UDP, which would also be useful for Quick.
Lars, I was quickly going to reply to this. So this API exists already. If you look at TCP info, for example, right, you need to poll it kind of, but it does tell you when your TCP connection retransmits, and you don't see the loss, but if you see that counter go up, you can sort of infer that something has happened at a lower layer. It's an ugly API, and it's not at all related to any socket API or that, but it is there on many platforms, right?
And that also gets into how do we expose TCP encapsulation, because one approach to doing it is kind of make it hidden for the application, just take their packets and stuff them in a TCP pipe. If they are aware that they're going over TCP, then they could check this.
Hi, Jay Collin. The middle box seems to be the problem here. It's dropping UDP, right? So without insight into the reasons that they're dropping UDP, or do we have this insight? Is that documented anywhere? I'm not really clear whether encapsulating in TCP is just going to also get blocked after DPI, and then it'll have to be inside TLS. And
Yes,
as you saw, but
you can put it inside TLS and put it over port 443.
So is that going to be the next step of the recommendation if we make the TCP?
I don't think we want to recommend that. That was an interesting line we flirted with for the Ike stuff, and essentially we just defined, here's how you put it over a stream, and left it at that.
Is there a channel to provide suggestions for standards for middle boxes? Maybe that's out of scope. Sorry.
So it's a different discussion, but just because we write something in an RFC, it might not happen, And I'm not sure if it makes, even if the situation gets better, it might not make this use case going completely away, because in some cases your business cannot risk to just have not connectivity. So you really want to have a solution.
Based on my understanding, UDP is mostly used for real-time service. Even ESP is used, for example, in the enterprise. The voice of IP in the enterprise widely used, also use the ESP. But my concern is that for your performance set, you're only talking about the delay or not the loss rate and the perform of the throughput, but there's no loss rate and the delay, because for the voice over IP and other real-time service, the delay and is very critical for some real-time service. For my understanding, I needed some these performance test and some or some evaluation. Otherwise, for the real IP side kind of real-time service, maybe have some problems in the enterprise environment.
Yes, I definitely think that if you are running a UDP protocol that's being used for real-time services, calling and stuff, that the effects of the delay, the bursty delay that you get from fixing up the loss on the outer TCP connection would be fairly visible in certain cases.
And also they have used some DSCP to different service. But for the TCP, even you use DSCP because this sequence number dependent. So even use DSCP is no use for the TCP connections. So my main concern is how to support some real-time, some different service if TCP encapsulation is used.
Right, and that is definitely an open question of what do you do with per packet markings like ECN or essentially the traffic class markings on packets when you're putting them inside a stream. And you could say drop them, you could say apply them if they're uniform within that segment that you're transmitting, but that would need to be discussed.
So Spencer Dawkins is the responsible area director for a few working groups that are relevant to about what I'm about to say. First is, it seems like, as we're headed this direction also, the TAPS working group, when we chartered it, was pretty, Pete Resnick leaned over to me during the BOF and said, this is right on the hairy edge between research and engineering, but I like it. And, now we're saying, oh, well, but we need to be looking at the security, transport security protocols as when we're picking a path, and we're saying, oh, we need to be looking at address families as we're picking a path. And I'm waiting for somebody to send me a recharter request for TAPS that says we need to be looking at things like loss rates and stuff like that, so we'll know whether to start doing things like that. So the second thing I was going to say, and I'm taking off my AD hat. The second thing I was going to say was, if I knew anything when I got to the IETF, it was that running TCP over X25 was the wrong thing to do, and that was a long time ago. And I think it's really a good thing for us to say. Well, with fast retransmit, you can get away with a lot of stuff that you couldn't get away with when you really had two reliability mechanisms that were beating on each other a lot more violently than what you were seeing was beating on each other. And the third thing I'm going to say is I'm waiting for the day that, since Quick runs over UDP and it has really state-of-the-art at loss recovery, I'm waiting to see if anybody tries to run that over TCP as a fallback. And now I'll go sit back on the stage. You're welcome. Oh.
Hi, Stuart Cheshire again. I just came up to answer the question that Jake asked about why we have short timeouts for UDP. And I think it's a good question because we often forget the reason for that. In the IETF, we generally don't like middle boxes, but there are places where they provide a useful service. The battery on my phone would run down if random strangers could bombard it with packets. So I'm actually glad that my phone carrier has some kind of stateful firewall, maybe not a NAT, maybe it doesn't need to translate V6 addresses, but I do want it to block unwanted traffic. And I think that will continue to be true for battery-powered devices and many other cases. So TCP has a fin bit. The middle box knows when the connection is over, and because of that, it can keep the state, trusting the client to give it a fin bit and say, I'm done now. As long as UDP has no fin bit, the middle box will just accumulate piles of stale state and never know when they were done. So UDP, I think, inevitably has to have short timeouts. And I worked on PCP, port control protocol, which was an attempt to provide signaling there, but I don't think there are enough incentives for carriers to deploy that. So we're back stuck with there being no way to know when a UDP flow is over.
One option, which would be interesting to consider, is if Quick being over UDP provides the correct signaling and middle boxes do adopt that connection went away type of signaling for Quick, how hard would it be to essentially take the approach that's bad for TCP of, oh, send it in something that looks like TCP but don't really do TCP, to do that with the Quick wire format to say, let's send what looks like a quick packet, but not actually be running reliability within it, and just use that as your encapsulation method.
I have not been following Quick closely. Is there a move to put a visible fin bit equivalent in Quick that middle boxes could see?
I would defer to the people in the room who would know the answer to that question as of about 2 hours ago.
Okay, sounds like.
No pressure.
Yeah. Hi, Brian Trammell. It's been discussed. There was an issue filed. There was not really interest in it because the working group didn't see it as a problem. It's just basically like
So
I think
we
what's
don't care
in the
about delays
0-1
longer
of
than
the
20 seconds.
I think what's in the 0-1 of either the applicability or manageability draft, or it should be in there, is, hey, you're going to be dealing with short timeouts. So if you don't have anything to send over 30 minutes, that's why you have a ping frame, right? That's the 30 second. I said 30 minutes. Yeah. 30 seconds. Yeah. So
20
it's like
seconds.
ping every fast is the guidance now. If that's not what it should be, there's a working group and there's a GitHub and you can file the issue again. But I don't think there's a lot of appetite for that.
Yeah, and thank you all for the clue on that.
Kyle Rose. So this goes back to it's related to the quick discussion, and someone just pointed out that why don't we just use quick without reliability and assume that that's going to somehow keep the firewall state open. Earlier we discussed just using a TCP header with no TCP stuff involved. What if we use the state machine of TCP, but not the congestion control, the recovery mechanisms, reliability? Would that be horribly breaking, or?
What you're describing pretty much is Jana Iyengar's research work, which was called Minion. He had a bunch of academic papers, and we had an implementation of using something that looks like TCP so it gets through the network, but actually we can do our own thing inside the payload. And what we found is you end up having to mimic TCP so closely that you are in fact TCP. One of the things about Minion was it had a mechanism to skip retransmissions. If the data was timely and it was stale, it would just skip the sequence number ahead. There were enough middle boxes that would recognize that as bogus and tear down the connection. So we had to retransmit the data we didn't want anyway. But as long as that was only less than 1% of the traffic, it wasn't a significant overhead to send the data we didn't want. And with fast retransmit, it's only one round trip late. We just ended back with TCP.
Yeah.
I love the internet. I'd just like to say that.
Hi, Jay Collins again. I just want to mention that there was a set of drafts called Plus that tried to talk about this very problem. As I recall, it got a mixed reception, sort of. And
that's fair. I was sitting at the front of the room. That's fair.
Yeah. So, I mean, maybe the question is the recommendation that we should re-examine these mechanisms in light of the feedback that was given then to address this problem that is still present for UDP.
So, I mean, I would love to, but I don't think that's the solution people look forward to right now, because it's something that has certain deployment effort and will not happen tomorrow.
Last second, not talking about Plus. So one difference with Quick in this space is, right, so because of zero RTT, a client actually has a pretty low overhead to just establish a new connection when the binding state times out. However, you still have the problem, what if you want a connection open without pinging constantly? Yeah. And that is not solved. But at least these sort of overhead that you have with TCP over TLS over TCP with opening a new connection is gone, or not nearly as bad.
Right. And to that point, the reason that this came up for us with Ike was not about outbound connections, because Ike has Mobike. We can reestablish in one RTT. It's great. The problem was that we were using these connections to receive incoming phone calls,
Yeah.
and we need to be camped. And so if we ever want to use some variation, maybe it's quick V2 or something like that, to receive incoming pings on a long-lived like push-style connection, then we'll need something to indicate to the network that I'm still around, don't kill me.
Right. And right now that's ping. Right now that's that packet every 10 seconds. But yeah, so
that
this
drains
is-
your battery.
Yeah. Right, exactly. But so you go ahead, because I'm probably going to say what you're going to say, but
I don't know.
I'm just going to say what Lars said. So.
But if not, you get 2 turns. So the problem with, so it's ping and it's probably going to stay ping. And the reason is that even if we did put the bits on UDP traffic, by the time a middle box gets up to actually do something different will be pretty long given the update cycles. And how do you know before you send the traffic, or even while you send the traffic, that you have a path where you have such a middle box, so you don't have to ping so frequently? Right.
Yeah, there are mechanisms
run
to do
into
that.
the binding timeout a couple times.
Right. You start with something low, and then you just wait slightly longer. You keep increasing the timeout between
Right.
pings 10 seconds until you lose it.
It only helps you after a long time, where you don't move.
That's true. That's true. But for mechanisms that do need a long-lived connection to receive incoming phone calls, if I can do this discovery mechanism over the first hour I'm in my hotel, and then be able to only send a ping every hour from that point on.
It's called, PLPTOD, path packetization layer path timeout discovery.
Here you go.
Yeah.
If I could
Yeah.
just mention one thing here, my close personal friend Aaron Falk is in the process now, I think, of trying to figure out if we're supposed to be doing another hot RFC lightning talk round later in the week. I don't, I mean, he's trying to figure that out. I think he put out a doodle poll saying, do you need to do this, and would you come, and stuff like that. I haven't looked at the doodle poll, but whatever he asked, he's asked. If that happens, I would recommend that somebody get up and say that and see who follows them out of the room.
Okay, good point. I did actually, the thing that I was going to say, what Lars said, I do actually want to get up and say that again. So what Lars said, no, with respect to a stop bit on Quick, a reason not to do that is, okay, we're uncertain if it would get used, and for the current application that Quick cares about, which is HTTP, as HTTP is often used but not always used, like there are things that do stuff with WebSockets that are going to fall over in interesting ways. But for right now, for vanilla HTTP 3 or whatever we're going to call it over Quick, it doesn't really get you anything. And for the deployment lifetime of version 1, yeah, the deployment of middle boxes will be negligible. But it's probably something that should be re-raised when we talk about putting other applications on top of it. Because there are applications where having a long-lived connection where either side could decide at some point to send, you need to know that state's there. And maybe the solution is PLPT, whatever, timeout discovery. And maybe the solution is some sort of timeout discovery plus some sort of signaling, with the hope that some sort of signaling will be used in the future.
Or alternatively, the recommendation, at least in the meantime, is you have a TCP connection open to receive that.
Right. Yeah, you could do
and
that
then
too.
you do Quick in response to it.
Right. You could do that too. And
We'll
you
have to see how it pans out.
you could migrate the crypto. Yeah. Okay.
Yeah.
Yeah. Crypto step. Okay.
Yeah.
Cool. Thanks.
If I could do just a AD interrupt kind of a thing here, we've got, is it 7 more minutes? Is that right? And we always try to end TSV area with the opportunity for the community to get up and tell us, the ADs, what the ADs need to know. Was anybody planning on saying anything at open mic time? And if you are, just please raise your hand so we'll know.
So I guess we're actually wrapping up this discussion anyway. So
Yeah.
I'm happy that nobody freaked out and screamed at me when I said TCP encapsulation. So that's a good sign. I think there's interest in providing guidelines, and you committed yourself right now. Okay, perfect. Sure. Perfect. So if
Should be a group
there's
effort.
any more people who wants to help, just contact Tommy. And I think that would go to TSV working group. Actually, we don't want to see it here again. I'm also happy that people have a lot of ideas about what to do about encapsulation, so we should keep talking. And thank you very much for this discussion. So now if you have any other thing you want to scream at us, go to the mic. I'm taking this as a sign that everybody's absolutely happy with our work. Great. Let's go for dinner.
Yeah, thank you all. Travel safely out of here and travel safely into Montreal. And hi to our listeners at home. Bye-bye. Could you unplug me, so?